In this lecture, we will discuss complex line integral. Let fz be a continuous function at all points of the curve C which we assume has finite length. That means our C, that is C is measurable, C is rectifiable curve. We subdivide C into n subarcs by means of the point Z0, Z1, Z2 dot Zn, where A is equal to Z0 and B is equal to Zn. On each arc joining points Zk minus 1 to Zk, where k ranges from 1 to up to n, we choose a point psi k as shown in the figure. Draw this figure. Suppose this is my curve C. This is the point Z0, which is equal to A, and this is Z1, this is Z2, this will be your Zk minus 1, this is Zk, this is Zn minus 1, this is Zn, and it is equal to B. Consider the sum. Here it is, suppose psi 1, here it is psi 2, goes on it, here it is psi k, here it is psi n. Consider the sum. Sn equal to above psi 1 in the length of the interval Z1 minus Z0 plus above psi 2 Z2 minus Z1 plus dot plus above psi n Zn minus Zn minus 1. On writing del Zk equal to Zk minus 1, Zk minus Zk minus 1. The above sum this become sum over k ranges from 1 to n above psi k delta Zk. we increases the number of subdivision in such a way that land that largest chord length del zk approaches to 0, so that the sum approaches to a limit which does not depends on the mode of subdivision. This limit is denoted by integral a to b fz dz or fz dz called complex line integral. That is, if we increase the number of subdivision in such a way that the length of the largest chord approaches to 0, so that the sum approaches to a limit which does not depend upon the mode of subdivision, and it is denoted by this is called complex line integral, or simply line integral, or line integral of fz along the curve C, or the definite integral of fz from A to B along the curve C. In case the initial and terminal point of the curve coincide, then the curve is closed curve. The curve is closed curve, and integral is called contour integral denoted by integral c fz integral c fz dz. Next, a complex integral over a curve can be reduced to integral of real valued function. Suppose this is a complex integral of a complex valued function, integral over c fz dz. Then we know that fz is equal to u plus iv and z equal to x plus iy. This implies dz is equal to dx plus I dy, so that this becomes now integral c fz dz equal to u plus iv then dx plus I dy over c. If you expand this right hand side, you will get if you expand this, you will get u dx plus I square b dy. Okay, this u dx plus I square b dy. So then again plus I b dx plus I u dy. Plus I b dx plus u dy. Now this is integral of real valued function. Here my variable is x and y, so using property of integral, this will be, this I square will be minus 1, so this will be minus 1 b dy. Using property of integral, I is constant, so taken outside, b dx plus u dy. So complex line integral can be reduced to two real valued integral of two real valued function. We will discuss the example later on. With that, I would like to conclude. Remaining will be in the next lecture. Thank you.